The Great Plains of the United States covers an area from Texas to North Dakota and from the Front Range of the Rocky Mountains to the Mississippi River Basin.
The Great Plains region has a diverse climatology with a strong west to east precipitation gradient and strong north to south temperature gradient. The region has frequent severe weather events, a high evaporation potential due to the solar radiation, and dry air and high wind due to the relatively flat terrain. During El Niño years, the winters are colder than average and the summers become warmer, along with greater than normal precipitation across the region. Since the 1930s, there's been a widespread increase in temperature and a decrease in the precipitation, with the strongest fluctuations occurring during the summer. Research has shown that a 2 degrees Celsius warming corresponds to a 20% increase in the frequency of heavy precipitation events.
The Great Plains is known for its wide variety of weather, which includes extreme temperatures and temperature swings, snow, flooding, drought, and the popular one, severe storms. But what drives this weather, and more specifically, what are the key drivers of precipitation over the Great Plains, or lack thereof?
There is a wide variety of winter precipitation processes across the Great Plains, with freezing rain and heavy snow having the greatest impact. Freezing rain occurs whenever a cold front pushes south from Canada, with the freezing rain usually occurring on the back side of the cold front. Heavy snow forms whenever a low moving across the Great Plains will start to deepen, with the heaviest snow forming on the left side of the low track.
The low-level jet is a key driver of precipitation on the Great Plains. It is an area of increased wind speeds above the surface and is located between 250 to 500 meters, or 800 to 1500 feet above the surface. The winds are usually from the south and have a speed approximately 10 meters per second, or 20 miles per hour. The low-level jet typically occurs between April and December and is strongest during the night. The reason it is important is because it is the main transporter of moisture from the Gulf of Mexico to the Great Plains. It is one of the reasons for the presence of precipitation during summer nights in the region.
The main contribution of precipitation in the Great Plains occurs in the spring and summer months and is characterized as warm season precipitation. A majority of this warm season precipitation is associated with convective precipitation, which is defined as the precipitation produced from the vertical motion in thunderstorms. Most of the convection can be described as mesoscale convective systems, which includes lines of thunderstorms or broad areas of organized thunderstorms. While the maximum frequency in severe weather and rain events across the Great Plains occurs in the late afternoon and evening, heavy rain events occur most often after midnight. These mainly nocturnal precipitation events are driven by the low-level jet, large-scale fronts, and large regions of thunderstorms and stratiform rain. Mesoscale convective systems and other warm season precipitation events typically develop in very moist environments with a strong low-level jet, which helps to increase moisture transport.
Here is a sample 500 millibar or upper level map from a precipitation event on April 17, 2015. With the Rocky Mountains to the west of the Great Plains region, air aloft is stretched as it passes over the slope terrain, causing a surface low, broad circulation, which is known as least cyclogenesis. This upper level trough and the strong winds aloft promote vertical motion and cloud and thunderstorm development over the Great Plains region. The Gulf of Mexico acts as a large source of moisture for the Great Plains, and when a strong low-level jet is present, it can transport this moisture from the Gulf of Mexico to the Great Plains region. Coupled with this strong moisture transport from the low-level jet, and possibly a surface front, a strong MCS, such as the squall line with heavy precipitation, can develop.
Land-atmospheric interactions have the potential to greatly impact precipitation in the Great Plains. The Great Plains is a region with strong ties to agriculture, and therefore the irrigation of these crops can produce a sharp gradient in the soil moisture, and small-scale circulations can be created by this gradient. While irrigation is not a main driver of precipitation in the Great Plains, it does have the potential to enhance this precipitation.
One impact of precipitation in the Great Plains is flooding. And flooding occurs when there is strong winds at the surface and to the mid-levels. This is an example of a mid-level map. We have strong winds in Oklahoma and Texas, located right where the moisture convergence is, and so with the strong winds here and then weaker winds aloft, these are the perfect ingredients for flooding in the Great Plains. Flooding occurs where the precipitation is the heaviest for the longest periods of time, and they occur under the factors I've explained earlier. This happens when thunderstorms train or move over the same area over a long period of time. The processes that drive rainfall across the Great Plains are also responsible for the lack of rain when they do not occur, in turn causing drought conditions, which is becoming a greater concern across this region. When the low-level jet is weak, there are fewer convective systems during the summer, and drought conditions can start to form. The longer an area goes without significant rainfall, the harder it will be for the region to come out of the drought. Two visual droughts can be seen at Lake Altus and Lake Kemp, where after 6 years of drought conditions in the area, the spatial coverage of the lakes has greatly decreased.
Conclusions. There is a strong east-west precipitation gradient across the Great Plains. Snow falls typically to the left of the surface low. Freezing precipitation falls behind the cold front. The low-level jet is a main driver for moisture transport into the region. The combination of moisture transport with the development of a surface low front is a main driver in the warm season. Impacts from precipitation in the region include drought, the lack of precipitation, and flooding, too much precipitation, which can cause the loss of life and property to the public.